Again, welcome to tonight's webinar, and I don't think it's really any surprise that this winter was kind of warm and definitely a lack of snowfall. But here's a quick summary slide that we've got showing our four main climate sites of Boston, Hartford, Providence, and Worcester. And you can see definitely, yeah, the heat miser won out this winter. So sorry, snow fans, just wasn't your year. But you can see all of our sites had above average temperatures and pretty substantial departures anywhere. These are average temperatures, so we take the daily high, the daily low, and come up with an average for the day, and then we average it out through the 90 days of December, January, and February. I mean, 4 degrees at Boston up to over 6 degrees at Worcester. That's pretty impressive warmth for the winter months. And you can see for the most part, precipitation was above normal. Boston came in a tick below average, but certainly the snowfall on the far right, you can see was well below the averages on the order of 2 to 3 feet for the most part. So definitely, a lack of snow. And a lot of people have been asking, is this climate change and related to warmth? And, to some degree, yes, but you have to remember it all comes down to, basic weather patterns too. And about every 10 years or so, we tend to see a winter like this. The last one we had was back in 2011, 2012, if you remember that. It was a pretty mild and snowless winter, not as snowless as this one, but they do come around every 10 years or so. So looking back in the climate records, these do happen on occasion. But it all comes down to timing also. Do we have the cold air in place when we get our storms? And this year we just didn't. We had a little bit, but it kind of eroded pretty quickly, and we'll talk about the weather pattern too. So just as a quick reference again, temperature and precipitation for the winter, we look at December, January, and February. That's our climatological winter. But snowfall, we look at for the entire year. The actual season starts in July and ends in June. So that runs not just 3 months, but for the entire season. So we're still in our snowfall season for what it's worth this year. But I think we're pretty much, done. So let's start with some polls. And I was trying to come up with some questions here. What could we, talk about that weren't some leading questions? But I'll launch the first one here. So, were you happy or were you disappointed with kind of our mild and snowless winter? I know some people, love the snow and cold. And probably a majority of you, but I know some people like the warmth. It gives you a break from, maybe shoveling and having to warm up the car every morning. So, just out of curiosity, I think we're tilted towards snow levels, but I figure we'll see how we're doing here. So I'll just give it a couple of seconds, and then I'll close and show the responses. And looks like the disappointed folks are in the majority here, but not by too much. So let's see. All right. Looks like all our responses are in. I will close it, and you should be able to see the results here. So you can certainly see majority of you, 64% were disappointed. You want your snow and cold, and but 36% were happy, loving the warmth and the lack of snow. And hey, once in a while, it's certainly not a bad thing. We've certainly had our share of active winters around here. So, hey, for me, it was kind of a nice kind of break. All right, let me go back and we will go into the next question. So we have one more, and this is more of a forecasting question, and we'll talk about your forecast too. So did this winter meet your expectations? And I mean, from like maybe a forecasting standpoint, I think we all had a kind of an idea of, was it going to be warm and maybe, less snow than usual, or did you think it would be a lot more snow this winter? So I'm just kind of curious. I think most folks were leaning toward a mild winter with below average snow. Looks like that's what I'm seeing so far. But just out of curiosity, you never know. So let's see. Looks like our polling is almost done. Let's see. Okay, yeah, we are closed. Let me close this and share it. So yeah, and you can see the majority said yes, I'm expecting a mild winter with below average snowfall, 69% of you. And the other 31% said no, thought we were in for a lot of snow. And again, given this winter, if we had one storm where the cold air was in place or, things came together just perfectly, we would have, at least gotten one decent storm. And we saw that last winter, if you remember the end of January, we had the big blizzard, and that was really our biggest storm of the year. It just all comes down to timing every year, no matter kind of what the pattern. So, all right. So with that, I'll close those polls right there, and we'll keep on moving here. So we're going to start just a quick summary looking at our 4 climate sites, a quick overview. And again, probably no real surprises here, but here's a look at Boston at Logan Airport. It was the 5th warmest, 7th least snowiest winter in station history. The snowfall goes actually back to the late 1800s, but you can see a chart here of kind of day-to-day temperatures on the bottom. with the highs and lows and kind of the averages and the extremes. And you can see we're certainly living in this middle zone here is the average, certainly living in the warmer end of the curve through most of the winter. Certainly a little bit before Christmas, we had one cold shot, and here's our more impressive cold shot that was in early February. We'll talk about that, and then one a little bit later in the month. But you can see for the most part, definitely, an overall mild winter. And here's a look at the accumulated snowfall on a graph. The average snowfall for a season is this brown line. You can see which gradually ramps up through the season. Our observed snow was well below that. You can see a lot of distance between the two curves. A little bit of snow in December, a little bit in January. We stepped up a little bit, and a little bit here in the middle of February, but certainly not a lot by any means, and well below average for Boston. For Providence, fourth warmest winter in station history, going back to the early 1930s. You can see the statistics there. Well below average snowfall, above average precipitation. And again, looking at the temperatures, most of the time we're in the average or above average part of the curve with our two cold shots before Christmas, and again, the first weekend in February, and again, a little bit toward the end of February. But overall, just a mild and snowless winter for Providence. And another look at Providence's snowfall in the same curve. You can see certainly there's a lot of area under the curve between the average snow and the brown line and the observed snow with the green. So again, not a lot of snow for the coastal areas this winter. The interior, you'll notice as I get to them, a little bit less distance between the two curves, so a little bit closer to normal there. And speaking of which, looking at Hartford, it was the fourth warmest winter in station history. So again, top 5 warmest winters almost across the board, and just outside of that at Boston. But again, living in that warmer part of the curve, even a few record high temperatures in there for good measure. But certainly you can see our 2 cold shots, almost 3 cold shots, kind of stand out through the winter. But really not a lot of below average temperatures this past winter, and only a little over 15 inches of snow at Bradley. So certainly that's well below average as well. And you can see the curve here looking at the average versus observed snowfall. Not quite as much as distance between the curves as Providence and Boston, but certainly below average snowfall there as well. The largest snowfall was occurring later in the month in February, but that was about it. And then for Worcester, this was the warmest winter in station history, believe it or not, with a mean temperature of 33.7 degrees. Snowfall about half of average, and precipitation a little bit above average. And following the theme of the other stations, a lot of time in the pink part of the curve, showing kind of above average temperatures, and just our 3 cold shots stand out as well in December, early February, and later in February as well. But that was about it. So again, warm and snowless winter. And for Worcester, definitely not as much room between the two curves. You see, a little bit more in the way of snowfall across the interior. Areas to the northwest of Worcester actually fared out the best. Portions of northwest Massachusetts, and that was really thanks to that mid-March storm. But even areas, central northern New England, the ski areas did very well this past winter. That's where really the whole axis of heavy snow was for each of our kind of warm storms down in this neck of the woods in southern New England. And just looking, here's a table across, looking most of the eastern United States. This was through the end of March, so essentially that's our snow season. And you can see a lot of areas had below average snowfall. But some areas did pretty well. Buffalo did well. Remember, we had those 2 extreme lake effect events. Caribou, not just a little bit above normal, about 20 inches above normal there. But most of the areas at or above normal in central northern New England. Certainly areas in upstate New York were below average. Much of the Northeast below average. And even if you look at New York City, only 2 inches, a little over 2 inches in Central Park and at JFK Airport, which is obviously well below average. So for the most part, again, a below average snowfall winter here in much of the eastern U.S. Only areas of really northern New England and near the Great Lakes did pretty well. So let's look at our winter forecast contest. So thanks again to everybody who entered, and we've got our winners right here. For Boston, it was our friend Tom A. He did very well. You can see this was his forecast right here of, I believe, 30 inches, which was above, but it was the lowest out of all the guesses. Jeannie H. for Hartford, almost spot on. She guessed 24, and the total was 24.2. Joe, I know you're on tonight. You were our winner for Worcester at 53, just over the observed of 47.2. And Michael R. for Providence did the best. He had the lowest at 25.7, and the observed was 11.6. So kind of like the Price is Right. You know, closest without going over, I guess. We all went over, but who went over the least was kind of the winner in all situations. And I will tell you, for the sake of honesty, Bill Leatham and I were these top two, and we were below, but not quite below enough. So we got beat out this year by all of you. So, hey, pretty good job across the board. Really, everybody kind of was at, or below normal. This is the consensus forecast here in the second yellow line here, which was kind of the average of all of them. And we were pretty much below average across the board. So Providence tilted just a tick above, but for the most part, everybody's forecasts were below. We had a few people go above. Which, hey, again, if you get one or two storms that are timed out just right, we certainly could have been there. So great job, everybody, and I hope that was fun. And we'll plan to do that again next winter, see if we can get more people involved in our forecast. So great job, everybody. All right, so what was the dominant jet stream pattern? Well, if you were following a lot of the weather briefings, it was kind of like a broken record, and this is what you saw. We had really a persistent ridge shown in this pink shading here in the east, and that was January, even December, January, and February. Some sort of ridge, either the Great Lakes or Northeast, and that's when we got into those kind of mild spells where it was in the 40s and even 50s for some cases. And we had a lot of these troughs that were coming in across the North Pacific or off the Pacific Ocean. If you remember, there was a lot of heavy mountain snows across California and the Rocky Mountains, and a lot of heavy rain even in Southern California. Those were these systems moving onshore, and eventually they would come into the plain states and lift out across the Great Lakes to our west, and that puts us on the warmer side of the storm. Whereas if a system could dig to our south and pass off to our south, then we'd be on the colder and snowy side. But just really didn't happen, with maybe one or two exceptions. Our storm track was really focused across the Great Lakes for much of the winter, and that just keeps us warm and kind of wet as opposed to getting more in the way of snow. And what was interesting was, and we'll talk about La Nina here in a minute, in a typical La Nina winter, we tend to see the storm track farther north in the Pacific. This was really unusual, seeing so much rain and snow, California, Nevada, into the Rockies. Typically, the Pacific Northwest does a lot better and is a lot wetter, and it just didn't happen this year for whatever reason. It really was kind of an atypical La Nina pattern. But that, in a nutshell, these two images kind of show you pretty much the whole winter pattern, and it was just very, very persistent. So when we talk about the El Nino and La Nina, and we're actually going to be talking about going into an El Nino pattern, likely during the summertime, it refers, just as a quick review, those sea surface temperatures off the coast of South America and the Pacific. So if it's below average temperatures, as seen on the top, this is a La Nina. If we have warmer than average temperatures, that's an El Nino. And we're transitioning now out of the La Nina, which we've been in for about the past 3 years. We're kind of going neutral now in between the two. And a lot of our models and expectations now are for us to go into an El Nino pattern with warming as we head into the summer. So our summer outlook, we'll get into a lot more detail about what we can expect from that. But the La Nina influence, typically, this is what we see, as I mentioned, wetter conditions in the Pacific Northwest and sometimes in the Great Lakes, tends to be, colder in the northern tier of states. We're kind of, in the middle, in the battleground. We can kind of go either way. And then it's definitely drier in the southern tier of states. But this whole pattern really shifted south quite a bit. We saw wetter conditions in the Southwest, wetter conditions, especially in the Gulf Coast, a lot of severe weather as well. So, again, this doesn't always tell us the whole story for the winter. What we're in was kind of a weaker La Nina years, which can be mild and wet, which was. But most of our patterns are pretty transient, meaning they change quite a bit from, over a couple of weeks at a time. So we tend not to so much look at La Nina for an overall sense. It does have some contribution, but we tend to see more transient weather features that kind of shift the pattern after a few weeks. But this year it certainly was very, very persistent. So as I mentioned, La Nina is likely transitioning to El Nino, and we'll certainly get into more of this in our summer outlook on May 16th. But this was the third consecutive winter dominated by La Nina, and as you can see here on this forecast, things are trending above the line here. The zero line is kind of neutral, and we're expecting to go into La Nina by June, July, August timeframe, and through much of the summer. So stay tuned for that, and we'll kind of talk about things in our summer outlook. About kind of what can happen here in southern New England. All right, so let's go take a look back at some of the more notable storms of this past winter. There weren't too many, but we did have some that we, want to probably just do a quick walk back in time. If you remember, just before Christmas, we had a pretty mild storm, December 22nd and 23rd. It featured high winds along many areas, coastal flooding along both coasts, and even a rare ocean effect snow event on the Cape and the islands. So we'll just quickly go through that. This was the weather map. We had low pressure deepening rapidly as it tracked through the eastern Great Lakes. Again, track west of us is a warmer track, so it favors more in the way of rain versus snow. You can see a lot of those isobars packed in across the area. That means strong winds, and it did produce damaging winds across much of southern New England, a lot of downed trees and power lines. And the southeast flow that we have, along with the astronomical high tides, actually led to some pretty significant coastal flooding on both the east and the south coast. That's a pretty rare event. Normally, with our storms, we see it along one coast. Either it's along the south coast with a southerly flow, or it's along the east coast when we have an east or northeast flow. But in this case, the winds were just right out of the southeast to kind of bring it to both coasts, and we'll talk a little bit more about that. But more importantly, behind the storm, if you remember, and this lasted kind of into Christmas Eve, a blast of Arctic air, which was on southwest winds, produced a rare single band of ocean effect snow and really affected Cape and the islands, especially Martha's Vineyard, upwards of 8-9 inches of snow on the island, and gave those areas a white Christmas, which kind of was a surprise even to us. For the coastal flooding, as I mentioned, we had what's called minor to moderate flooding. So think about moderate flooding is water about 2 to 3 feet deep. And, that was on both coasts. And the water levels on the south coast were among the highest we've observed in about 10 years. And Providence, as you can see here on the graph, got just above 9 feet, which puts it in the moderate flood stage. That's the first time since October 29th of 2012. And the surge was just over 3 feet. That was a combination of strong winds, also a contribution of 15 to 20-foot seas offshore, and channeling of the water up Narragansett Bay. So really led to a pretty high impact across Narragansett Bay. Even at Quonset Air Base in Rhode Island was flooded quite a bit onto the runways. So there were pretty significant impacts from this event. And then the ocean effect snow, this was a look at the radar that evening, the night of the 23rd into the 24th. This is pretty impressive to see on our radar out of Taunton. Don't really see this very often at all in a southwest wind, and there's a webcam shot at the time. And you can see the convergence from the shoreline extending all the way from Long Island Sound. You can see the band extending to Block Island and Martha's Vineyard there, and even more bands south of Long Island over the ocean waters there. And this is all due to good wind convergence. You can see you've got slightly northwest winds along southern Connecticut and almost little southwest winds along the shore of Long Island here. So that gives you a convergence zone, and that's what ended up producing our rare band of lake effect snow on southwest winds, something we really just don't see very much. Typically, when we have southwest winds, the Arctic air is leaving, and we may see some brief ocean effect snows with that, but not when the air is coming in. Normally it's on a west or northwest wind, and we get the smaller multibands. So that was certainly a rare event for us. But as we mentioned in the review, it could have been worse for you snow lovers. This was the forecast office in Buffalo. They received 43 inches of snow up to Christmas morning, and at that point brought their seasonal total to just under 93 inches, which was just 2 inches below their average for the entire winter. And the backstory with this is the forecasters, 5 of them, got stuck in the office from, I believe, Thursday morning through Christmas Day. And even one person got stuck till Monday, the day after, on Christmas. So they were just completely isolated from just about everything. There was so much snow falling. And we did have an event review on this. If you want to go back to our YouTube channel, Dave Zaff, who works at the Buffalo office and is a native here of Massachusetts, helped us out with that. So you can get a full review on that Christmas storm, lake effect storm, which was pretty historic for the Buffalo area. All right, so our next storm in series was the January 15th to 16th offshore storm. So this was one that looked like it was going to be kind of a miss, an offshore storm. The models did very well on it several days advance, and there were some hints of what's called a warm core system. We'll talk about that in a minute. But there was a trough that extended back from the low well offshore, brought us some rain and snow, mainly to the coastal areas. And the system was pretty slow to depart, which is typical in the model bias. The models tend to lift these things out way too quickly. So it hung on a little bit longer than what the model showed. And again, forecasters kind of recognized this bias and kind of hung onto the clouds and the rain and snow showers a little bit longer than the model showed. If you remember, this is a quick look at the satellite loop, and we had these bands of snow kind of pivoting southward around the outside of the low as as the storm remained offshore. And a lot of these were in the form of rain, but as some of the heavier bands came through, they were in the form of snow showers. Most notably, you'll see one come through in a second here, coming down. This was about rush hour during the morning of the 16th, and actually produced some snow. That was it right there. But didn't stick too much outside of the grassy areas. But the precipitation type was really driven by the intensity. So when it lightened up, we kind of saw rain and just some very light snows. And then when it got heavier, it pulled some of the colder air aloft down and forced a change over to snow. So at least we had a little bit of something there, but more, decorative snow than anything else. These are some of the totals that we saw from CocoRa's observers. Kind of a widespread 1 to 3 inch snowfall. You can see some areas along the immediate coast, North Shore of Boston picked up about 4 inches, a little bit higher in Plymouth County as well. And in fact, for the season, Plymouth County actually did pretty darn good for snowfall totals with a couple of ocean effect snow events, and including this one. But for the most part, this was just a general light snowfall with really not much of an impact on the roads as surface temperatures were kind of warm. Now, when we talk about a warm core system, we're talking about a tropical system, believe it or not. And there was a lot of discussion about this. And Boris Konan, who we know through emails us quite a bit at the office, had mentioned this to us. And you could see, this is the Canadian RGEM model forecast. It really shows what looks like a tropical system with a well-defined eye over the kind of the Gulf Stream. And the satellite image from the GOES, this was observed, actually kind of shows some structure to it. We saw a lot of warming nicely here. It certainly passed over an area with high precipitable waters over the Gulf Stream, warmer temperatures. Temperatures were approaching about 72 Fahrenheit. So it was, definitely feeding off those warmer waters. And, he was saying he wouldn't write it off yet as a subtropical cyclone. It certainly could have formed into one. And in fact, there was a special tropical outlook issued by the National Hurricane Center, and they talked about this non-tropical low producing some thunderstorms near its center, but the low overall was embedded in cold air. Remember, there was an upper low over it, which is cold air aloft, and it was eventually expected to track away from the Gulf Stream over colder ocean waters. So it was unlikely to transition into a subtropical or tropical cyclone. But nonetheless, it was certainly worthy of some discussion, just to mention that, there's some stuff going on out there that looks a little bit suspicious. So, kudos to the National Hurricane Center for, at least addressing the fact that there was something out there that potentially, could have become subtropical, but just wasn't going to stay over the warmer waters for a long enough period of time. Okay, then, probably one of the more frustrating storms of the season was our snow bust, January 25th to 26th. And this was kind of a common theme this whole winter. We had very marginal surface temperatures for the snow to stick, marginal temperatures aloft for rain or snow. And it's these marginal kind of situations. They tend to happen early in the season and late in the season in a typical winter. But this winter just seemed to be endless of these situations. We had a coastal low. It brought some snow, but really mainly heavy rain and strong winds to the region. The snowfall forecasts were overdone, especially across the interior. We kind of thought that classic front end thump was expected, where you've got the cold air in place, the precipitation's moving in, so you'll get this burst of snow before the warmer air finally wins out and changes everything to sleet and eventually rain. So that was a little bit overdone with the expectations of the cold air, but rainfall and flooding forecasts, the wind forecasts were, certainly more accurate. But I know for you snow lovers, this one was certainly a disappointment. We ended up with 2 rounds of precipitation, if you remember, from this storm. There was an initial band of snow that moved through, which was our warm advection, the warm air moving in. That moved through the region faster than expected, and that's another model bias. The models tend to be too slow with that first burst of snow that comes through. And then the second round of rain, here's the first initial burst, not much to it. And then the second round was mainly rain as it moved in, with some snow initially at the higher elevations. But there was a bit of a dry slot in between the two. Wasn't forecast well even by the high res models, which tend to do very well on Wednesday, and you can see the system's finally departed. So this first was our burst of snow, not much to it, very light, low reflectivities, and then for the most part, rain moved in after that with some snow in the higher elevations. But overall, just a little bit too warm to get much in the way of heavy snow. So why did this happen? Well, if we look up at about 18,000 feet or 500 millibar level, this kind of tells the story. Our main shortwave or trough that we were looking at was really too far to the west, and as a result, all the lift stayed out to the west with this trough. You can see it's back across the Great Lakes, and really we didn't have much in the way of lift present over us at all. Just a little bit initially as the warm air moved in, which is shown here. But most of the lift was with this short wave, and it pivoted more into Canada as opposed to tracking over the Northeast. And by the time this lift did arrive, it was certainly warm enough really to just support rain as opposed to snow. So you can see in the morning, 7 a.m., the air is initially cold enough over southern New England to support snow, but really wasn't enough cold or enough source of cold air to produce a prolonged period of snow, especially near the coast. You can see it's already pretty marginal into the 30s. There's really not a big source of cold to our north. Winds aren't really out of the north either, with a few exceptions. This is a situation you really have to have the Arctic air in place, temperatures in the teens, low 20s, to get that really good front-end thump of heavy snow, and it just wasn't there. Okay, so on to our big shot of cold for the season. This was February 3rd and 4th, our brief Arctic blast. It was the second period of really significantly below average temperatures for the winter. The first, as I mentioned, was just before Christmas. We had strong and damaging winds accompanying the arrival of the cold air, and we saw the coldest temperatures and wind chills since February of 2016. The models and ensembles did a very, very good job at showing the potential for this extreme cold nearly a week ahead of time, which I think really helped everybody prepare for this, which was, kudos to the models. Did a really good job of picking this up. If you remember, here's a look at our record cold across the board, well below zero in some spots. Records set across the board on Friday, February 3rd, except for Hartford. But then all of them set records on Saturday, February 4th. And this was the first time Boston reached 10 below since January 15th of 1957, when it was 12 below. So you can see we pretty much shattered most of the records, especially closer to the coast. So pretty impressive shot of cold. And the winds, 50 to 60 miles per hour, accompanied this, as high as 66 miles an hour in Martha's Vineyard, 62 miles an hour in Worcester, and you can see other wind speeds there, but really widespread 40 to 60 mile per hour winds across the region, which really added to the cold. And when we get these Arctic air masses, it's not unusual to see what's called Arctic sea smoke. It was visible in many bodies of water. We got some shots from Vineyard Haven Harbor on the right, Boston Harbor below. And this is what forms due to the temperature difference between the Arctic air mass and the relatively mild water. So it's like taking a day, hot day in July or August, opening your freezer, you see all the what looks like steam coming out. That's Arctic sea smoke. That's the cold air, quickly warming up, and with the temperature difference between the air mass and the body of water. So we also saw really extreme icing, and icing rates, I haven't seen this in years. Really more typical of the Bering Sea than southern New England. You can see on some of the buoys here, the Mass Bay buoy outside of Boston Harbor, almost 1 inch per hour. Nantucket Sound over 2 inches per hour. And east of Nantucket, Nantucket Shoals, almost 2 inches per hour. And, these are heavy to extreme icing rates, which are extremely dangerous for any vessels that are out there. And the freezing spray forms when we have the air temperature below the freezing temperature of seawater, so roughly about 28 degrees Fahrenheit. You also need winds of about 18 knots or higher, so a little over 21 miles per hour. And the lower the air temperature and stronger the wind, the more rapid is the ice buildup, along with a moving vessel. And it's most common in our waters in January and February, when we tend to see these Arctic outbreaks. But really, I haven't seen icing rates like this in, probably easily 20 years. So this is a very much an extreme and rare event. If we look at the observed sounding from Gray, Maine, just to our north, this was another interesting fact. You can see how low the tropopause, that's the top of where our weather occurs. Typically, it's a lot higher up in the atmosphere. It can be 30, 40,000 feet. This was down, almost at 800 millibars, which is just maybe 7,000, 8,000 feet, and was actually below the top of Mount Washington. So for a time, Mount Washington was actually in the stratosphere as this cold air mass descended, down upon us. And on Mount Washington also, there was a wind chill that got down to minus 108 degrees Fahrenheit. That set a new record for the lowest wind chill in the United States, the previous being minus 105 in Alaska. So beat that out. And certainly this is about as cold an air mass as you're going to see in our part of the region with these temperatures. The 850 millibar temperature, minus 35.5 Celsius. That's almost unheard of, that cold. But on the heels of it, if you remember, we had a dramatic warm-up 24 hours later. Sunday, February 5th, temperatures were, 50 degrees or higher in some areas. And many areas you can see on this map saw rises of over 50 degrees in a 24-hour period. So it was a quick, brutal shot, but it was out of here by the next day, and we were back to our typical warm pattern for the winter. So certainly something to remember from this past winter. And closing out in our winter, well, we'll close it out with the biggest storm of the winter season, our March 13th to 15th nor'easter. This dumped over 2 feet of snow in the higher elevations of Massachusetts, widespread damage and power outages, especially out near the Berkshires and northern portions of Worcester County. Also produced high winds near the coast, some minor coastal flooding, but not a lot. Also gave us some minor river flooding from heavy rain and certainly hazardous marine conditions. And if you remember, I think we're going to show the snowfall map in a minute, but this was a really challenging storm from a forecasting perspective. It was pretty much a lock that the higher elevations were going to see the heavy snow, and that's where the forecast was certainly most accurate. But elsewhere, again, marginal temperatures, 33, 34, 35 degrees, really gave a lot of uncertainty as to how much would stick, and forecasts were definitely overdone outside of those higher elevation areas. The main question was, where would the surface low track? Would it, cut back toward Boston? Would it stay offshore? How much would it strengthen, which would, really determine how much cold air will be drawn into the region. Also some wind and coastal flood concerns, and then eventually river and stream flooding, as you can see here. So we had everything on the map from winter storm warnings to river flood warnings, wind advisories, just about everything you can imagine in one storm. So here's a map of our observed snowfall from the storm, and you can see the higher terrain certainly stands out with totals over 2 feet. And this 37-inch total in East Hawley is being investigated for a potential 24-hour snowfall record for the state of Massachusetts. That's going to take probably several weeks to get done, to kind of write everything up and verify that the measurements were done accurately. But certainly looks like we might have a new 24-hour snowfall record for Massachusetts at 37 inches. Out in East Hawley. So stay tuned for that. We'll have more on that in the coming weeks. But as you can see, the coastal areas, little to no snow, generally less than 3 inches, 2 inches once you got closer to the coast, where it still snowed, but just was a little bit too warm to allow it to stick. But there was heavy rain in several corridors of 3 to 4 inches plus of rainfall, over 4.5 inches in West Warwick, Rhode Island. Portions of eastern Connecticut, Rhode Island, eastern Massachusetts, well over 3.5 inches of rain. Produced a lot of highway ponding, street flooding, but also some flooding on the smaller rivers, such as the Patuxent River through Cranston. And here's a quick look at a radar loop, just kind of showing the evolution of the storm as you remember this. The rain-snow line, initially extended from northern Connecticut into central and northeast Massachusetts. It wobbled a little bit in the morning, eventually collapsed to the southeast in the afternoon, but at the same time, we had drier air working into Rhode Island and eastern Massachusetts, so we ended up having lighter snowfall rates. That caused the precipitation to kind of mix with or even go back to light rain for a time, cut down on snowfall totals there as well. So really was just more of an elevation snow event. As it was still, areas outside of maybe around 495 in Massachusetts got a little bit more snow, especially in the northeast part of the state. But for the most part, just kind of a couple of inches of snow did it for most of the coastal areas. All right. So with that, that's a look at our past winter. Again, not too many storms compared to previous winters, but certainly some notable events as we went through December, January, February, and March. At this point, we will pause here and take some questions before we get to our weather briefing or comments. So let's see. Jonathan says all points bulletin on the heat miser. Yep. So we'll see. Let's see. Comment from Joe on the windy precip days. Some of the precip doesn't make it into the precip gauge of Boston. Yeah, that's true. It does undermeasure it a little bit, and that might have something to do with the below average rainfall there. So that's a good point. That's kind of a known issue and something that's trying to be worked on with putting a windscreen around it, but not always perfect. So let's see. Looks like from Sebastian. Yeah, good comment here. Looks like the past winter was really a kind of a what-if scenario in all aspects. Substantial above average precip at most climate sites. Makes you wonder what could have been if we had colder temperatures in place. ahead of the storm systems that rotated through. Absolutely. The storm track seemed unfavorable for the majority of the winter as well, with the mean surface low tracks thoroughly entrenched further to our west. Yep, exactly. He sort of resigned himself to the fact that his forecast wouldn't verify once we hit late January and the track had not budged. At that point, I could see, more or less the writing on the wall. Yeah, sometimes we see this pattern evolve in November, December, where everything goes to our west, and eventually, as we get into late January, February, things shift east, and we start to see more offshore tracks. But boy, I'll tell you what, this was just so persistent. Just didn't happen this year. So there you go. Let's see, more comments here. Living in New England his entire life, he's learned to embrace the distinct seasons that we experience. So he wants winter to look like winter. Yeah, some of the thing is too, we've really been spoiled. I mean, if you go back to through the 2010s, especially, we've had a number of significant blizzards. I mean, go back to the winter of early 2015. We got, eastern Massachusetts, Rhode Island got hit pretty hard. Blizzard of 2013 is another good example. Even in the 2000s, we had a good blizzard, 2003, 2005. So, is this kind of a balance to all that? Maybe. We have to expect the law of averages is kind of going to give us a warm and snowless winter every once in a while. So definitely had some good ones, but it does happen, as well. From Bill, is the mild winter portend anything for the rest of the year as far as temperatures or drier weather? Not necessarily. There really isn't a strong signal if we look at a winter versus the following, spring or summer. But this summer, we're certainly going to be seeing what looks like the emergence of El Nino that tends to give us our warmer summers. It can also give us drier summers too, believe it or not. We've been starting to look through some of our past records at El Nino years, and a lot of the drier years were during El Nino. But again, in the summertime, our precipitation is hit or miss from showers and thunderstorms, maybe even a tropical system. So gonna kind of have to see how things pan out there. But the odds might favor a warmer and maybe drier than average summer, but we'll just kind of have to see. Again, our patterns change over a couple weeks at a time, so we'll just have to see. Nothing that we can definitely lock our eyes into. Let's see. So Bert says, after the winter in April, Cape Cod got into the mid 80s. Yeah, how does that happen to 42-degree water? Great question. We had that nice shot of 80s and even 90s, in April a few weeks ago. This time the winds were more out of the west, Bert, so really negated the influence of the 42-degree water. When we get our west winds, those are our hottest days, as you probably know, on the Cape and the islands in the summertime. And this was a good example of that. Just enough westerly flow off the land to kind of prevent anything from coming from the southwest, which cools us off tends in the spring. So that was certainly a rarity too. I guess I could include that in the winter summary, our record warmth in April. From Fred, no big storms near the benchmark this season. No, really didn't have too many. We had a couple of offshore storms, and everything else tracked kind of to our west, or we had a weaker secondary low kind of move right over us in a lot of cases too, which is just a warm storm. So let's see, from Tom, any hunches on winter 2024? Oh boy. Well, I'm going to show you the CPC outlook when we get to that in the weather briefing. But right now, I think they're favoring kind of, again, an El Nino dominated winter, which for the most part can be a warmer than average winter here, but also a wetter than average winter here. So coming down to timing doesn't mean everything's going to be rain. We can get some snowy winters in El Nino winters too. So odds would favor definitely more snow than this past winter, maybe return to more normal, even above normal. So we'll have to kind of see how the pattern starts to shake out in the fall. That's when we start to see kind of how things will at least start for the beginning of the winter. But right now, I think the odds are favoring above average temps and maybe above average precipitation. So we'll see how that evolves. Let's see, from another one from Sebastian. Do you think there's any relation to the West Coast, notably California's historic above average snowfall totals and their almost historic warmth observed? Anecdotally, he tends to see a bouncing effect take shape, with which happens across one coast can reflect the opposite. Yeah, typically that is what happens. Big trough in the west along the west coast. We're usually seeing a ridge out here in the east, and as I showed, that was our dominant weather pattern for the winter. Our big winters, when we get those big troughs here in the east and the flow comes right up the coast, there's often a very large ridge over the Rockies or close to the west coast. So it's usually the opposite of what's happening here. Very often when we get into a big cold snap here, they're seeing a lot of warmth up in Alaska and the Pacific Northwest. So, yeah, that's a great observation, Sebastian. Typically, it's about all the it's almost the opposite from coast to coast in our situation. So, and Fred just wants to know, drier meaning less rain or less humid? Oh, less rain, Fred. Sorry. Not less humid. Humidity, good luck forecasting that more than a few days in advance. But yeah, drier meaning less rain overall. But again, I'm not going to hang my hat on that at this point. So um, let's see. And Jonathan mentioned, yeah, El Nino years 2016, big snowfall in the Mid-Atlantic. Yep, 1983, yes. A couple of doozies. President's Day in February, absolutely. So yeah, those were two big El Nino years. I don't know if we're going to get quite as strong this year. We'll be looking at that. But that will certainly have a role into next winter's expectations. So we'll just have to kind of wait and see on that. All right.